Hello everyone, I'm Rene and I'm the coach for Team NeuPro. I have the pleasure of introducing these 7 amazing developers, and of course it's such a joy to work with our customer Thomas, and of course our project lead is Sajad. The team has such an amazing demo to show you today, so we need a lot of time, so I'm just going to let Asan get straight to it.
Thank you, Rene. So let's start. How many of you have ever tried assembling IKEA furniture? Then I'm pretty sure you've seen something like this. And you wondered, what on earth is the difference between the two of these screws? Do I use this one or that one? And you've probably also wondered, what on earth is that thing? Is it a screw? Is it a nut? Why is there always one left over when I'm done with my furniture? Imagine the life of an industrial worker. It's not one screw he or she has to deal with, but hundreds and thousands of screws. And these screws, these are going into complex parts like aircraft engines. So you know, if you and me, we end up messing up our furniture, it's okay. Our chair might end up looking like this, but we will live to see the day, at the end of the day. But imagine this happens to an aircraft while it's flying. Does not look very good, does it? This is exactly where we come in. So what we did, we came up with a convolutional neural network which is able to classify screws and bolts and all kinds of industrial items at speeds unknown to man. We are able to, this allowed us to move the industrial worker away, put him in a managerial position, and let the neural network take care of the classification. So the camera simply takes a picture, lets the neural network decide what it is, and the worker, in the worst case, we make a mistake, which is highly unlikely, by the way, can tell the neural network, correct it in the future. So enough of this. To show you this system in action, I would like to call Marcel up on stage. Marcel?
Good evening. Probably you remember me from our last presentation when you called me and my grandpa in our top secret lab. This time, I'm live here on stage to show you the latest changes to our system. If you think back, last time we were able to reliably classify 9 different screws. We wanted to challenge ourselves and be able to classify even more screws. But that's not enough. Let's go for more. But as you can see, screws only, that's not really exciting. So we wanted to make things a little bit spicy. And we have added some washers to our system as well. Even though we have a right variety of screws now, our system remains super stable and accurate, and even my old grandpa is able to operate it on his own. To prove you this, I would like to ask Professor Brügge to choose one or several parts.
I'm not your grandpa. Pick another one. Okay.
And while Professor Brügge can think about what part he would like us to classify, I'd like to call my grandpa in our secret lab.
Now you clarified that, then I select
Sorry.
Okay, I selected. Okay, here we go. S13.
S13. Let's see. Grandpa, you're sleeping again. I told you we have this presentation today. Wake up. Grandpa.
It's Weiberfastnacht.
Can you hear me? Okay, looks like my grandpa is waking up. So, Professor Brügge has chosen screw 13, right?
S13, yes.
S13 to classify for us. So, and here on the other screen you can see our iOS application that can show the classification result. My grandpa takes a photo of the image, and the image is sent to our classification server where the neural network performs the actual classification and sent right back to our application. As you can see, the part has been perfectly classified. So Thank you very much, Grandpa. You can go back sleeping again.
This is something which is not very easy to achieve. From a machine learning perspective, if I were a classifier, it would be very easy for me to say, all of you are humans. But to be able to tell each and every one of you apart by your faces and by your names is no easy task. I would need tons of pictures of each and every single one of you in order to be able to do this. So the question is, how did a bunch of students at TUM, with their state-of-art hardware, manage to achieve results that are so good? Exactly. Let's find out. Marcel?
When we started, we had 9 different classes, and of each class, we had 200 200 images. We then increased our data set to 34 classes and had, again, 200 images of each class. Furthermore, we artificially increased our data set by using different augmentation techniques. But let's have a closer look what this actually means. Behind the scenes, we had some serious trouble with different lighting conditions. In order to make the system more robust to changes in light, we have applied a technique called intensity or light augmentation, where you can simulate different lights. Furthermore, to make the system invariant to changes in position, we applied random rotation, shifts, and flips. With these techniques combined, we were able to build a really robust classifier. But enough of all the server and neural network stuff. We've also implemented an iOS application that can show you what is actually going on our server. For this reason, I would like to invite Debbie, who will guide you through the application.
Thank you, Marcel. So just imagine you're a maintenance worker and you need to find the right screwdriver. So therefore, you can just use our overview screen where all the different classes of items are listed. So for example, you go on the screw 10 that you need and you see all the relevant information about it, like the measurements or the purpose. You can even look up more detailed information in the manual. So if you want to see all the lately classified items, you can just swipe to the history screen and have a really beautiful overview of it. But what happens if the rare situation occurs that our system classifies an item wrongly? Well, therefore, we have our online learning model, which provides feedback to the system. Let's try it out. Looks like Grandpa's been messing around with our system again. And I don't think this is 211. So to tell the system that this is wrong, I will swipe to the right and get the second highest confident, which is screw 15. And I guess it's also not screw 15. If it would be right, I could swipe left to confirm it, but it's not, so I'm swiping right again. Now I can finally type in the right class, which is Grandpa, of course. To confirm this, I swipe to the right, and as you see, it's immediately updated. It's also updated on our server, so our classification model can now train based on the corrected results. So just imagine you need to find the right position in the engine to fit the screw. Therefore, you can use our super nice AR function, where you just scan the item with our neural network in CoreML, and then you get the bounding box of our engine and send the coordinates to our AR screen. Therefore, we first have to calibrate it so it gets more precise. And now, after some tapping, I get the exact position of where the screw belongs, and I can screw it in. So now that you've seen all of our implementation, our goal was to actually classify 20 similar items, but we even achieved to classify 34 similar items. We also wanted to achieve a 97% accuracy, but we even achieved a 99% accuracy in our test data. As you've seen, we also implemented our online learning model, but we were not entirely able to embed our system into the real environment because we only had access to cameras that were not compatible with our system, so we didn't have enough time to switch. As we don't have the real plans of an engine yet, we have a proof of concept for our augmented reality. The new release of ARKit will provide a feature called 2D image recognition, which exactly fits our use case, so our AR feature will be more stable. Then we will have an automated dataset creation, so we can add hundreds of more classes, and we want to classify a wider variety of small parts. Then we will also finally switch to industrial cameras, and the actual sorting will happen with a robotic arm. So thank you to our customer, NeuPro Solutions, and Thomas Neumeier. Do you have a question for us?
Hello team, I will thank you for the presentation and the good work. And my question is, which future works could improve the system and how?
So at the moment, we can classify the parts that have a really unique shape, and to be able to classify more complicated parts, we could use different camera perspectives and train on a neural network that has several inputs for all the images and fuse those information down in a deeper stage and then provide the final result. So this is how I imagine we can achieve better results with complicated parts.
Okay, thank you.
Thanks.
Before we forget, we are also having a live demo afterwards, so please come by to our booth where you can classify all different types of things that you want to. So yeah, please come by.